For millennia, they have haunted our skies. Ominous portents, celestial ghosts, streaking across the darkness without warning. Pause 1 south, we've called them the hairy stars, messengers of gods and omens of doom. Pause 1 south, but in the modern age, we gave them a much simpler, cleaner name: dirty snowballs, a simple ball of ice and dust. Leftover debris from the all formation of our solar system? It's a neat, tidy explanation, and it is completely, fundamentally wrong. Asterisk, what if I told you that inside these frozen wanderers lies not just dust, but the very chemical blueprints for life? Asterisk, that these snowballs can be as black as coal, have the texture of deep-fried ice cream, and contain minerals forged in fire. Today, we journey deep inside the heart of a comet, peeling back its layers to reveal a world far stranger, far more complex, and far more important to our own existence than you have ever imagined. Our modern journey into the heart of a comet begins in 1950. The solar system was still a place of vast unknowns. We knew comets were icy, and we knew they had tails that appeared as they neared the sun. But what were they? Asterisk, the prevailing theory was the flying sandbank model, suggesting they were loose clouds of gravel and dust. But this couldn't explain the immense gassy outbursts that created their magnificent comas and tails. Then, astronomer Fred Whipple proposed a revolutionary idea. He pictured a comet's core, its nucleus, as a single, solid body, a conglomerate of frozen water, ammonia, methane, and carbon dioxide, mixed with silicate dust and rock, a dirty snowball. As this snowball approached the sun, its surface ices wouldn't melt, but sublimate, turning directly into gas. This explosive release of gas would carry dust with it, creating the glowing atmosphere, or coma, that we see. The pressure of sunlight and the solar wind would then sweep this material back, forming the iconic tails. It was an elegant, powerful model that explained almost everything we could observe from Earth for decades. Whipple's dirty snowball was the undisputed truth. It transformed comets from supernatural omens into understandable, physical objects. But science never stands still. Asterisk, when we finally got close enough to touch them, to taste their chemical makeup, and to land on their surfaces, we discovered that dirty snowball wasn't the full story. It was just the title page. Asterisk, the reality hidden beneath the ice was something else entirely. A complex, porous, and chemically rich world that holds the key to understanding not just the solar system, but perhaps even ourselves. Asterisk, the deception wasn't intentional. It was simply the limit of our vision. And what lay beyond that limit was about to change everything. Imagine holding a piece of a comet in your hand. You might expect something cold, hard, and heavy, like a chunk of ice-laden rock. You would be wrong. Asterisk. The first big surprise from missions like Rosetta was just how incredibly light and fluffy these objects are. The nucleus of a comet is one of the least dense objects in the solar system. Its density is often less than half that of water. If you could find an ocean large enough, a comet would float. Asterisk, this isn't a solid block, it's a cosmic sponge. Its interior is thought to be up to 85% empty space, a fragile, porous structure of ice and dust grains loosely stuck together, like a frozen aerogel. Asterisk, this fluffiness is a pristine record of its birth. It tells us that comets didn't form through violent, high-pressure collisions. They formed through a gentle, slow-motion ballet of particles in the freezing outer solar system. delicately clumping together over eons. But the weirdness doesn't stop there. Asterisk, while we call them snowballs. Comets are paradoxically some of the darkest objects known to science. Their surfaces are covered in a thick crust of organic compounds, complex carbon-based molecules, which have been baked and altered by eons of exposure to cosmic rays and solar radiation. This process, called space weathering, leaves behind a tar-like, black residue. This crust is incredibly dark, reflecting only 3 to 4% of the light that hits it. That's blacker than asphalt, blacker than fresh coal. Asterisk, so you have this incredibly light, porous, icy interior, hidden beneath a superheated pitch black, organic crust. This led scientists to a new, more accurate, and far more delicious sounding analogy. Deep-fried ice cream, asterisk, the cold icy treat is hidden within a dark, cooked outer layer. And it's this outer layer that holds the first clues to the complex chemistry hidden within. For most of its multi-thousand-year orbit, a comet is a dormant, frozen ghost, drifting silently through the abyss far beyond Neptune. In this state, it is just a nucleus dark, cold, and dead. Asterisk, but as its vast, elliptical path brings it into the inner solar system. It awakens the distant sun, once a mere pinpoint of light, grows into a furnace. And this is where the magic and the violence begins. Asterisk, the sun's energy begins to heat the dark crust of the nucleus. Heat penetrates through the porous surface, reaching the volatile ices buried just beneath. Frozen water, carbon monoxide, carbon dioxide. These aren't your everyday ices. Carbon monoxide boils at a mind-numbing -191 degrees Celsius as the nucleus warms. These super volatile ices don't melt into liquid. The vacuum of space causes them to sublimate, exploding directly from a solid into a gas. Asterisk, this process is not a gentle fizz. It's a series of chaotic, explosive outbursts. Gas pressure builds up beneath the dark crust until it violently ruptures the surface, blasting out focused jets of gas and dust at supersonic speeds. Asterisk, these jets can be thousands of kilometers long. They act like rocket thrusters, unpredictably spinning and altering the comet's rotation, and even its path through space. All of this liberated gas and dust forms a temporary, glowing atmosphere around the nucleus called the coma, while the nucleus itself might only be a few kilometers across. The coma can swell to be larger than the planet Jupiter, sometimes even larger than the Sun itself. Asterisk, it is this vast, transient cloud, lit up by the Sun, that makes a comet visible from Earth. The dirty snowball has become a celestial dragon, breathing fire as it charges towards the Sun. Asterisk, it is a spectacle of self-destruction, a necessary sacrifice to reveal the secrets it holds within. When we picture a comet, we picture its tail, a luminous smear across the night sky. But look closely at any detailed photograph, and you'll see that a comet doesn't have one tail, it has two, and they are profoundly different. Asterisk, they are sculpted by two separate and distinct forces emanating from the Sun. The first, and more visually obvious, is the dust tail. This is the broad, curved, yellowish-white tail. It's composed of the larger particles, the dirt from the dirty snowball, that were carried away by the escaping gas. These particles are relatively heavy. They are pushed gently by the pressure of sunlight itself. Photons of light, despite having no mass, carry momentum, and this constant, gentle shower of light acts like a faint wind, pushing the dust particles away, because the particles retain some of the comet's orbital momentum. The dust tail tends to curve gracefully behind the comet, It's essentially a trail of cosmic nucleus. Asterisk, the second tail, is stranger and more ethereal. The ion tail, or gas tail. This tail is often much fainter, straight as an arrow, and glows with a distinct, ghostly blue light. Asterisk, it's made not of dust, but of gas from the sublimating ices that has been ionized by the sun's intense ultraviolet radiation. This means the atoms have been stripped of their electrons, giving them an electrical charge. These charged particles, or ions, no longer respond to the gentle push of sunlight. Instead, they are grabbed and violently flung away by the solar wind. Asterisk, a supersonic stream of charged particles, constantly flowing from the sun. The solar wind is far more powerful than light. Pressure, so it forces the ion tail to point directly away from the sun. Regardless of which way the comet is moving, the blue glow comes from carbon monoxide ions fluorescing, absorbing ultraviolet light and re-emitting it in the visible blue spectrum. Observing these two tails is like seeing the invisible forces of the solar system made visible. Asterisk one is a whisper of light, the other a magnetic gale, and together they create the unforgettable spectacle of a comet's journey. Comets are born in the deep freeze. They are relics of the coldest, most distant reaches of the protoplanetary disk, the swirling cloud of gas and dust from which our solar system formed. This is their defining characteristic. They are pristine samples of the primordial, frozen outer solar system, which is why what NASA's Stardust mission found was so utterly baffling. Pause 1 South in 2006. The Stardust capsule returned to Earth, carrying microscopic dust particles it had painstakingly collected from the coma of Comet Wild 2. When scientists examined these particles, they found the expected mix of ice and simple carbon compounds, but they also found something that shouldn't have been there. Asterisk. Crystalline silicates, minerals like olivine, a key component of the green sand on some of Care. A key component of the green sand. On some of Earth's beaches, this was a shocking discovery. These types of crystals can only form in incredibly hot environments, well over 1,000 degrees Celsius. Asterisk, they are forged in fire, not in ice. Asterisk, they form in the blistering hot regions, close to a young star. So what were materials forged next to the infant sun doing inside a body that formed billions of kilometers away? Asterisk, in the cosmic freezer of the Kuiper Belt. Asterisk, the only logical conclusion was as dramatic as it was profound. In the chaotic infancy of our solar system, there must have been a massive, system-wide mixing event, material that was superheated near. The sun was somehow violently ejected outwards, all the way to the distant regions where comets were forming, and incorporated into their icy structures. Powerful jets from the young sun, or the gravitational turbulence of forming gas giants, could have acted as a cosmic fountain, flinging inner system material to the outermost edges. The discovery of these fire and ice particles completely overturned our tidy models of solar system formation. Asterisk. It proved that the early solar system wasn't a neatly ordered place. It was a violent, chaotic blender, and comets are the frozen, undigested evidence of that ancient turmoil. For decades, the idea was pure science fiction, relegated to the fringes of scientific thought. PANSPERMIA. Asterisk, the theory that life, or at least its essential ingredients, didn't originate on Earth, but was delivered here from space. Comets, as ancient, water-rich bodies, were the prime suspects for being the delivery vehicles. When we finally analyzed cometary material up close, we found that this fringe idea might just be the truth. Asterisk, missions like Rosetta and Stardust were equipped with incredibly sensitive instruments called mass, spectrometers, capable of identifying the exact chemical makeup of the gas and dust in a comet's coma. What they found was a chemical treasure chest. Asterisk. They didn't just find simple molecules like water and carbon dioxide. They found a rich, complex soup of organic compounds, the carbon-based molecules that form the backbone of all known life. Asterisk. Rosetta's instruments, sniffing the atmosphere of Comet 67P, detected dozens of different organic molecules. They found formaldehyde, a building block of sugars. They found ethanol, the alcohol in beverages. But then, they found the smoking gun. Asterisk. In 2016, scientists confirmed the unambiguous presence of glycine. Glycine is the simplest of the 20 amino acids that our cells use to build proteins. It is a fundamental, non-negotiable building block of life. Asterisk. And it was floating in the gas coming off a comet. They also found phosphorus, another critical element for life. Phosphorus forms the structural backbone of our DNA and RNA, and it's the key component of ATP, the molecule that carries energy in our cells. Finding both an amino acid and elemental phosphorus together on a single comet was a monumental discovery. Asterisk. It means that these icy bodies aren't just carrying water. They are carrying the molecular toolkit of life. They are cosmic couriers, delivering a sum-assembly required life-starting kit across the galaxy. Asterisk. The implications are staggering if comets carry these ingredients, and comets are common throughout the universe. Then the potential for life to begin on any habitable world is immensely greater than we ever dared to believe. The story of comets has always been one of extreme cold, born in the deep freeze and spending most of their lives there. We assumed they were frozen solid, through and through. But the universe is rarely so simple. Asterisk. Close-up observations of comets have revealed features that suggest a surprising past, and perhaps even a present, of internal warmth. On the surface of Comet 67P, the Rosetta mission discovered strange, circular pits, hundreds of meters across. They looked like sinkholes. Scientists believe these are formed when subsurface voids, created by the sublimation of buried ices, collapse. But the sheer scale and power required to create these features hinted that something more than just sunlight was at play. Asterisk. The leading theory points back to the very beginning of the solar system. The primordial cloud that formed the sun and planets was seeded with short-lived radioactive isotopes, like aluminum-26, as this material was incorporated into newly forming comets. The decay of these radioactive elements would have generated a significant amount of heat from the inside out. Asterisk. For a brief period, perhaps the first few million years of the solar system's history, the cores of comets could have been warm enough to host liquid water. Think about that. Asterisk. Not just ice, but vast pockets of liquid water, mixed with that rich cocktail of organic molecules we've already discovered, all warmed by a gentle radioactive glow deep inside a primordial comet. Asterisk. These weren't just dirty snowballs. They could have been the solar system's first chemical laboratories. Tiny, self-contained, life-generating test tubes hurtling through space. Asterisk. While this internal heat source would have died out billions of years ago, it fundamentally changes our perception of a comet's history. It provides a plausible environment where simple organic molecules could have linked together to form more complex structures, a crucial step on the road to life. We've dissected a comet's chemistry, But what would it be like to actually be there, to float within its coma and breathe in its ancient atmosphere? Thanks to the detailed data from mass spectrometers, we can reconstruct the scent of a comet, and it is not a pleasant perfume. Asterisk, the dominant smell would likely be the sharp, pungent odor of ammonia, familiar as a household cleaner, or, less pleasantly, stale urine mixed with this would be the unmistakable, nauseating stench of hydrogen sulfide, the chemical responsible for the smell of rotten eggs. Asterisk, these two overpowering scents would form the base of the comet's aroma. But there are more subtle and more sinister notes. Scientists detected hydrogen cyanide, a deadly poison that carries the faint, bittersweet scent of almonds, and formaldehyde, which has a sharp, pickling odor so far. Our cosmic perfume is a mixture of rotten eggs, urine, and poison. Asterisk, but it's not all bad. The chemical soup of Comet 67P also includes hints of alcohol, specifically ethanol, giving it a faint whiff of liquor, and most surprisingly, it contains a molecule called methyl isocyanate, which, on Earth, is responsible for some of the sweet, nutty notes in roasted cocoa beans. So what is the final bouquet? Asterisk, imagine a barnyard on a hot day, where someone has spilled a vat of poison and is trying to cover it up with cheap perfume and a box of chocolates. It's a bizarre, foul, and complex aroma. Asterisk, but this unappealing smell tells a beautiful story. It's the smell of chemical potential. It's the scent of a primordial world. A reminder that the building blocks of life are not necessarily clean and pleasant, but a messy, smelly, chaotic mixture of everything the universe has to offer. When we put all these weird and wonderful pieces together, the image of the comet changes completely. It is no longer a passive, frozen remnant. It emerges as one of the most crucial and active players in the story of our solar system's development, and indeed, our own. Asterisk, comets were the universe's ultimate delivery service. Imagine the early Earth. Over 4 billion years ago, a hot, volcanic, and likely barren rock. It may have formed relatively dry, with most of its water vaporized by the heat of its formation or blasted away by the impact that formed the moon. Asterisk, so where did our oceans come from? Asterisk, the leading theory points to the sky. A relentless bombardment of comets and asteroids over hundreds of millions of years. In an era known as the Late Heavy Bombardment, each impact delivered a payload of water ice, gradually filling the oceans and making the planet blue. Asterisk, but we now know they delivered so much. More than just water, their cargo was far more precious. Asterisk. Each impact was a delivery of complex organic molecules. The amino acids, the sugars, the ingredients of DNA, seeding the sterile oceans with the raw materials for biology. Each impact delivered phosphorus, the critical element for energy transfer and genetic information, and each impact delivered the acidic minerals forged in the heart of the solar system, contributing to the diverse geology of our young planet. Comets acted as a bridge, connecting the chaotic, fiery chemistry of the inner solar system with the cold, water-rich environment of the outer system. They mixed the ingredients, delivering precisely what was needed, where it was needed. Asterisk, they weren't just dirty snowballs, they were celestial architects. TERRAFORMING, our world molecule by molecule, impact by impact, transforming a dead rock into a living planet. We have journeyed from a simple, dirty snowball to a complex, life-bearing world that acted as the solar system's chemical delivery service. But for all we have learned, the ghost in the machine remains. The comet still holds its deepest secrets close. Asterisk, every discovery has only opened the door to more profound questions. We found simple amino acids, But could more complex structures like peptides form inside a comet's warm, watery past? Could comets from other star systems, interstellar visitors like Oumuamua and Borisov, be carrying a completely different set of chemical instructions? Asterisk future missions aim to answer these questions. Missions that could one day drill deep beneath the irradiated crust to sample the truly pristine, unaltered ices in a comet's core. A mission that could return a cryogenically preserved sample of the nucleus itself, an untouched fossil from the moment of creation, allowing us to study it in our labs on Earth. What we are truly searching for is a timeline. Asterisk. The story of our solar system is written in the layers of a comet's nucleus. By reading that story, we read our own. We learn about the violent, chaotic world that gave birth to our quiet, orderly home. We find the chemical ancestors of the molecules that billions of years later would combine on a small blue planet to look back up at the sky and wonder where they came from. Asterisk, a comet is more than ice and dust. It is a time capsule, a message in a bottle from 4.6 billion years in the past. Asterisk. It is the solar system's source code, and with every new mission, with every new discovery, we get one step closer to reading it. So the next time you look up and see a faint, fuzzy star with a tail, remember what you're truly seeing. Asterisk, you are not looking at a dirty snowball. You're witnessing a messenger from the dawn of time. Asterisk, a fragile, porous sponge of primordial ice, cloaked in a mantle as black as night. A chemical factory that smells of rotten eggs and bitter almonds, yet carries the sweet promise of life's beginnings. Asterisk, you're seeing the remnants of a cosmic blender that forged our solar system. Pause one south a delivery service that carried fire and ice, water and dust, and the very blueprints of biology to our world. They are not just visitors to our skies. They are our ancestors. And as they continue their silent, ageless journey around the sun, they carry with them the answer to our oldest question. Where did we come from? Asterisk, we came from the stars, delivered by the weird and wonderful ghost in the machine we call a comet.